So for number one, we're looking at a hypothetical square grows so that the length of its sides are increasing at a rate of 9 yards per minute. So we can go ahead and bring that down and say that our dy over dt will be equal to 9 yards per minute. And then how fast is the area of the square increasing when the sides are 4 yards each? So we know we're looking for how fast the area is increasing. So we can go ahead and say that dA over dt is unknown, and that's what we're looking for. And then while the sides are 4 yards each, so we can go and say that y will be equal to 4, and it is a square, so all the sides will be equal to 4. So then we're going to take our equation for area, so a equals y squared, and we're going to derive that, which will be dA over dt equals 2y dy over dt. So then as we chug it and plug and chug, we don't know what dA over dt is, so we're going to leave that as what we're trying to find. And then we can bring down the 2, and we can sub in the 4 for y right here. And then we can sub in dy over dt, we know is 9 right here. So then 2 times 4 is 8. 8 times 9 will be 72. And it's a square, so it's 2-dimensional, so we're going to square that. So our final answer is 72 yards squared per minute.
Okay, so question 2 is a hypothetical cube grows so that the length of its sides are increasing at a rate of 3 feet per minute. And then asks how fast is the volume of the cube increasing when the sides are 5 feet each. So I like to start by underlining the values. And then we know it's increasing. So first I draw the picture. And then we know the sides are 5 feet each. Put that there. And then it's increasing by 3 feet per minute. So I'm sure plus 2 there. And then so our volume formula is V equals y3, and this should be our y. So we know y equals 5. And then we're going to derive this d over dx. And then since we have different variables, we're going to combine the dv over dx equals, then with the, okay, so then you use the power rule here, and then you'll have 3y, and subtracting that by 2, and then you have to put dy over dx after that. And then you can just plug it in. So you'll have, we know our y is 5 from right there. So we'll have 3, 5 squared, and then we still have our dy, our dy over dx. We know is 3 because that's already changed. So we know that's 3. So we can plug that in right there, and then we can just multiply it out. And 5 squared is 25. 3 times 25 times 3, you know this is 75, and you can multiply that by 3, and then we know that our dv over dx is equal to 225, and then we have to do cubed because it is volume, so feet cubed per minute.
Okay. A 13-foot ladder is leaning against a wall and sliding towards the floor. The top of the ladder is sliding down the wall at a rate of 6 feet per second. How fast is the base of the ladder sliding away from the wall when the base of the ladder is 12 feet from the wall? Okay, so first of all, what we're given is we know it's going to be a triangle because it's a ladder facing the wall, and the ladder is 13 feet. So I'm going to mark the sides really quickly. I'll mark this as A, B, and C. So C equals 13 feet. And so the tip of the ladder. the ladder is sliding down the wall at a rate of 6 feet per second. So that means it'll be 6 feet per second. And since it is sliding down per second, it's a rate. So that means it'll be dv over dt equals 6. And how fast is the ladder going? So since the ladder is 12 feet from the wall, b will be 12. So from this, now that I have my given, I have to form an equation. So since it's a triangle, I'm going to use Pythagorean theorem. So a squared plus b squared equals c squared. And then I have to look for what I'm finding is basically the rate, or how fast the base of the ladder is sliding away from the wall when it's 12 feet away. So oh wait, this would be dA, not dB, excuse me. So what I'm actually looking for is dB over dt. Okay, so first of all, I'm going to start by factoring the problem. So 2a plus 2b equals 2c. Okay, so now that I have my factored equation, I can start putting in what I'm given. So first of all, since I don't know a, 2a times dA over dt plus 2 times 12, which is b, over dB over dt equals 2, and c is 13, times dc over dt. And now that I have this, I can start applying my rates. So first of all, 2 times, a should be there, times dA over dt, which is 6. And since I need to find a, and I'm basically already given 13 and 12, I could use Pythagorean theorem to find a. So it would be a squared plus 12 squared equals 13 squared, which is just 144 equals 169 plus a squared. And if I do the math, this is just a squared equals 25, so a equals 5. So now I can plug in my 5, and then add the 2 times 12. And since I'm finding dB over dt, I can't plug anything in for it yet. I'll just have to leave it. And 2 times 13. And dc over dt is basically how much the ladder is changing, like the rate of how big it's getting. And since it's an inanimate object, it's not really changing at all, so it's just 0. And now I can do the math. So this will be 0. 2 times 5 times 6 is 60. Plus 24 dB over dt. And since I want to isolate dB over dt, I'll get 60 over to the other side. So 24 dB over dt equals negative 60. And I'll minus 60 there. Now I could just divide out 24. So dB over dt equals negative 60 over 24, but I'm not done yet. I can first of all simplify. I can divide by 6, which is just negative 10 over 4, which is also just 2.5, or negative 2.5 feet per second. Is dB over dt. or how fast the base of the ladder is sliding away from the wall when the ladder is 12 feet from the wall.
Okay, so this is going to be the problem that we created. So your friend spills acid on the ground and it lands in a circular shape. The radius increases at a rate of 3 inches per second. How fast is the circle's area increasing when the radius is 36 inches? So first we can draw our diagram of a circle, and we know that it increases at a rate of 3 inches per second, the radius. So we know that dr over dt will equal 3 inches per second. And we know we're looking for how fast the area is increasing. So we're looking for dA over dt, and that's when the radius is 36 inches, so r will be 36. And then we can bring out the equation of the area of a circle, which will be a equals pi r squared. And then we can derive this using d over dt, which will make it dA over dt equals 2 pi r times, and then you have to add the dr over dt. And then we can use the things that we already have and plug in. So we don't know dA over dt, so that will stay. And then that will equal 2 pi, and then for the radius, we'll sub in 36. And then for dr over dt, we'll sub in 3. And then after multiplying this out, we find that dA over dt equals 216 pi inches squared per second. So that is how fast the circle's area is increasing.